All right. Then our next one. All the multiples of 10 that is less than 100. Let's see. So what Navashan did, he created a variables, a for loop variable, and then a num4. Num4 started at 10. Then he had a for loop that goes from 1 to 9. And then he said num4 must use num4 and just add 10 to it. So it was 0, it will add 10 to it, so it becomes 10, and then display it. And then the 10 gets 10 added to it, so it's 20, and then displayed. Then the 20 gets 10 and added, which becomes 30, and then displayed. And that would have happened up until 9, and then that would have given us our multiples of 10. Yeah, that's good. Did somebody do it a bit different that want to maybe tell us what they did? One alternative for this? Can somebody think of how else could we have done this? Displaying the multiples of 10 that's less than 100. Alright, so just to give you an idea, another thing we could have done was we could have said num4 um, must get the value of I times 10. So that would have now, I 1 times 10 is 10, then 2 times 10 is 20, 30, 40, 50, and that would have also done it for us. So, but it doesn't matter. This one will give you 100%, this will give you 100%. And I actually think there's other ways as well, but I can't think of it right now. But as long as you did it like that, then it's fine. It doesn't matter which way you did it. All right. So I'm going to go on. I'm going to count on all of you guys to tell me if there's something that went wrong. All right. So let's go. Now we go to the next one. 20 random 3-digit whole numbers. Do you have code for that? No, I don't think you could enter maybe. It's not here. All right. All right. Let's do this one. So we now here 20 random 3-digit whole numbers. So to save myself time, I'm just gonna copy this one's code. Just paste it there. So because it's whole numbers, everybody agree integer is good. All right. So but now it asked for 20 numbers. So what can I change to make this thing happen 20 times? What do you think? Yes, and what did you change in the for loop to make it 20? Yeah. So we'll just change that number. So making this for loop starting at 1 going to 20, this means everything inside will happen 20 times now. Now we just need to think we want it a 3-digit number. So what is the smallest 3-digit number we know? Well, just 100, I think. Yes, 100. And then, oh, you know what? Navashan. I think I see now the bot blocked it. Yeah. I saw sometimes some of the variable names, it's like because it's like coding wise, then it just thinks it's dodgy and then blocks it. All right, so don't worry. And what's our biggest 3-digit number we can get? 99. All right, so what do we put in our random range? 1,000. Because remember the last one is excluded. So because we want this one, we have to just add 1 to it. So that's why with the first one also, to have between 10 and 50, we went from 10 to 51 because it excludes that last one. So because we want 999, we'll put 1,000 there just to make it work for us. Right, and that would display that one. So that is good. The only problem we had with these numbers that you might have realized if you tried it and you ran it, if you click the first one, we see those numbers. Now, when I click the next one, it's underneath. It's not nice. And I'll clear button how we didn't do it. So what I would have done with all of these ones, just to test it out nicely, how do I clear redisplay? Yeah, you can actually just go dot clear as well. But dot lines dot clear does exactly the same thing, so that's fine. So we just do a dot clear just before all our for loops. And we can even do that maybe in the clear button, just to have it. So now that when we play our program, we can have that. And if we click all the different ones, and if we click there, we can get all the different ones. We click there. Oh, that's always it. Yeah. All right. And then, all right, now we're going to the next one. This one's a little bit more interesting. So with this one, I want 50 random real numbers rounded to 2 decimal places between 50 and 80. So this one's going to be interesting. Just, oh, not that. So I'm just going to take this code I had, and copy this code, just paste it there. All right. So let's look at what we need to change. Oh, so the question is 15 numbers. So what do I change to make it 15? All right, everyone good? The for loop. My 10, I just make a 15. So that will make it happen 15 times. So from 1 to 15, so then I just put that in there. So that will happen 15 times. Now it's at real numbers. So what data type should my num be then? Yes. All right, so num becomes real. I is still integer. Remember, I will stay integer because I is for counting how many times, and that will happen 15 times. So we're happy with that. Then to make our real also work, here on the inside, when it was into string, what should the int change to? Yes. All right, so we made the real work with that. Let's just do our range quickly. Between 50 and 80. So what goes here? Yes. 50,81. Now we're very close. Our only problem is if we run this thing, let's just quickly see. Even though we made it real, they are still integers. So how do I get a fraction in here now? Does anybody know? Have you done this before, maybe? I didn't show it to you. Okay. So in this part, this is where you need the other random. The only thing is you just say plus random with empty brackets. By just adding that, let's see what happens. See, now you get all this fraction part added. So you'll still see your between 50 and 80, and then a comma, and then lots of fractions. All right. So yes, try to remember that. So you'll just add a random with empty brackets. That will add a number between 0 and 1 to your number that you already generated. So now we've got a number that's got a lot of decimal places. So it doesn't look so nice. And then we remember the question said round it to 2 decimals. So do any of you know how can I round this num to 2 decimals? You know the round function. Yes, we can use round 2 as well. So we can say round 2, our num, and then comma, how many decimals do we want? 2. Alright, so now let's quickly see. So it's, round 2 is a little bit funny. So let's just quickly see what this does. Let me choose 1. Let me choose 1 just for now. Let's say we wanted 1 decimal place. Just to see nicely what's going to happen. So if I click it now, can you see what happened now? We can only see it as the tens part. So because we said 1, what this 1 refers to is actually 1 like on the left hand side of the comma. So this, when you say round to 1, it actually rounds to the tens. Round to 0 will be to the ones. So round to 2 would round off to hundreds. So now to go to on the other side to our decimal place, we must just say a negative. So if I say round to num to -1, it's going to do 1 decimal place for me. So you can see what it does, and then you'll see 1 decimal place. So, but this specific question wanted 2 decimal places, so we say -2. So if you're going to say round 2, if you put a whole number there, it's actually on the positive side, on the left-hand side of your comma. So it will round to tens, to hundreds, or tens, or thousands, or then 0 decimal places. But then if you want decimal places, you'll have to go negative to say, give me 2 spaces there. And that's our round 2 function. All right, all good. So we learned 2 new things again. So plus random just gives us a random number between 0 and 1. So it's just 0 comma something, which you can add to give it, make it a decimal. And then we can use round 2 to round it off for us, but we must just remember that we need to work with negatives to have decimal places. All right, so this one, yes, look. Well, you can use the round as well, but I knew all of you are going to want round 2 because round 2 is the same as random range. It's like the easier way, if I can say it. There's, I want to say the more generic one that will work in Java as well. Is like Java doesn't have a round 2 or random range. And then you remember with random, I showed you that in brackets, we're going to times it by the highest minus the lowest plus 1 plus lowest. What round 2 in like Java as well, they've only got a round function, which always rounds off to a whole number. So let's just so if we go round and then we say num. So that's going to round us. So there's no other parameters. You can just have it like that. And if we run it, we're going to have integers, which is not what we want. So to make round work, we have to think mathematical about this. So imagine you had a number 1, 2, 3, 4, comma 5, 6, 7, 8, 9, 10, and others. All right, now if you're using a round function that can only round off to an integer, does anybody have an idea what can we do if we wanted it with 2 decimal places? Any ideas that you can think of? So it's a mathematical thing we're going to do to it. So I'll help you. So what if, because we want two decimal places, you agree we want to keep those two, run off to there. So what if we times it by 100 first? So then we're going to get 1, 2, 3, 4, 5, 6, and then comma 7, 8, 9, plus all the rest. Now, after we multiplied it by 100, now we round it. So if we round this off now, to create this 7 is going to make that a 7, so it's going to become a 1, 2, 3, 4, 5, 7. Everybody still with me? All right. And now, but because we changed the number, we multiplied it by 100, and then we round it, we just have to reverse what we did. So now we just divide by 100. So then we get 1, 2, 3, comma, 1, 2, 3, 4, comma, 5, 7. And then we've rounded to two decimal places. So if you keep this in mind, so what we do with the round, we first multiply it by 100. Remember, what maths applies. So it will first do the brackets, take the number multiplied by 100, then we'll round it off, and after we round it off, we can just divide by 100 again. So that will also round it off to two decimals. If I wanted it to one decimal, how would I change that code to make it to round it off to one decimal place? What do you think? What can I do with that to round it off to one decimal place if I tell you that is for two decimal places? Yes. So then we'll just times by 10 and divide by 10. And if we needed three decimal places, yes, times 1,000, divide by 1,000. All right. So, but yeah, you do have the round function, so a round to function. So it would be nice to help, but otherwise the round. There's no other way to nicely round it off. Um, you can probably using the frac function, but it's just so difficult. So I want to say, yeah, you'll use one of these two. Decide which one you like. It really doesn't matter which one you want. As I said, what's nice about this top one is it's more generic. If you do think you want to go a bit further, I can't remember. Somebody asked me to maybe do like a Java course at the end of the term as well. Navashan, was that maybe you? Okay. Yeah, so we can do that, but then like when we do that, you'll see you need to use this way. So if you are seriously thinking you want to just like add this other language to you, I would say study this way of rounding because then it's exactly the same in Java because Java doesn't have a round to function. Yeah. And all right, I think that this one's good. So just remember now how round two works and then plus random for a fraction. Any other questions on this? All right. Then we've got one left. 10 random whole even two-digit numbers. Just sounds like a mouthful. All right. Okay, who wants to help me with this? So we're looking for 10 numbers. So do I need to change anything to make it 10? Yes, which is already. So we're happy. Yes, so we're happy with that. They said whole numbers, so we know it's integer. Yes, tell me, what would you do? Yes, well done. Well, 49. Okay, so this is what he's got. Does everybody agree or does somebody disagree? All right, so my question is, um, this is a possible answer. Would this work fine for giving me all whole even two-digit numbers if I've got that range? Okay, tell me, will I ever get 98? Yes, because remember this one is excluded. So we needed to go to 50 to actually just get 49. And then times 2 will give me my 98. Otherwise, if you go 49, your highest is 48, which is a 96 is your highest. Right, yes, and I think this is good. Let's quickly see. Those ones we tried, let's quickly see. Two digits, good. And they're all even, and they're all two digits. Yeah, perfect. And clear works, exit works, close works. All right, and that's basically that's loops. Or that's this is now what type of loop is this again? Is it conditional or unconditional? Yes. So remember, a for loop is unconditional, and then I'm just going to add yes. So the plus random um, gives us a real number between 0 and 1, and then this will round off two decimals on the right. So I'm going to say specifically two decimals on the right, so that if you guys like this code, I'll post again for you. And if you see this, to remember when you read it, you see on the right, it just sounds funny. Why did it just say two decimals on the right? And then you must remember that's why the negative is there. So the negative tells us it's two decimals on the right, while if it was positive, if it would have gone to two decimals or two places on the left of the decimal, which would have been something different. All right. Yeah. Any questions on loops, random numbers, um, any of these things? Or all of you sort of there? Ah, fantastic. Right. Okay, so what I'm going to do now, I'm going to show you how. Yes, talk to me. Okay, so you just click the save button. So okay, let me close everything. So when you open Delphi, go File, Open Project, and then go look where that folder is that you're busy working with. Something important to know, however, if you download it, okay, let me do this. So just remember, if we're on Google Classroom, if we're on Google Classroom and we go to our projects, look at math, and we go to our assigned listing, we open the zip file. Remember here we can't do anything, so we click on the dots, open in a new window, and then there's a download button. So then we click the download button, then it's going to download. So for this one, I'm going to put in another folder. I've got a folder here, Mika Math. I'm going to put it in there. So you save it there, wherever you want, it doesn't matter. And then what you do is, if you go to that folder where you saved it, you'll see there's a zipped file. Your icon might not look like mine, but it might be like a folder with a zip, like on the right. So what you have to do, you have to right click on it and say extract all. You have you have to do that. Then it's going to ask you where. Generally, it will start in the same folder as where it was. So you can keep it there, or if you want to put it in my documents or something, then you can change your folder. Then say extract. And then once you've extracted, you'll get another folder. So um, I think Shreya, with you that said you did it but you lost it. It could have been that if you didn't extract, the problem is sometimes if you go in Delphi and we go open project, and then you go to that folder, then okay, this time didn't work. But then if for some reason you can get into this folder, you can open it up, but because it's so compressed, you can't save back into it. So at the end, when you want to save it, it wouldn't save at all. So you have to first extract everything, and once it's extracted, this folder, you can then in Delphi go File, Open Project. Then you go to where you saved it. So in Micromath, I put it in there. Open that folder until you get to Projects. You click, you open, you'll see your program. Then in there, you go put all your code. You just click Save. Never go Save As. Just save. If you go Save As, it's breaking your program apart. It's gonna put your your jar file in one folder, and it's gonna put your form in another folder. So it splits everything up. So never go Save As. Just click Normal Save. Close Delphi if you want to, and then let's say you don't want it here in this folder. Then go remove this whole folder. Wherever you want to take it, take this whole folder to desktop or wherever you want to. You can cut it and then move it to wherever you want this thing. And that's, I want to say, so if you want to move where it is, do it with Windows, don't do it with Delphi. With Delphi, just click the normal save button and it will always save in the folder where it was located. And then once that is sorted, then you can just cut it and just go paste it wherever you want it. All right, we're good with the saving and opening and stuff. All right. Oh, I closed Delphi. Okay, so a topic I want to start with today is arrays. So for today, or after today's lesson, I'm going to give you again a very small homework similar to this one. And you saw like the one that I just did now. If you just copy and paste, like after you've done one, if you copy and paste it, it goes so quick because after you did the first one, copy your code, post it there, and just change it. Copy the code, paste it there, just change it. So I'm going to do something similar, but our only difference is I'm going to want you to put them into their own arrays. I'm going to want you to create arrays for each of them and put all these values into them. But I'll give you a whole new program for it. I'll give you the instructions and everything. It's going to take you maybe 10 minutes after it's downloaded and stuff. If you can download and save and extract, after that, it will take you 10 minutes to just try it before Tuesday, if you can. If you can't, it's fine. If you can, fantastic. So the whole idea, remember the problem that we've got with this program. As I explained, our array, our variable, can just keep one value. So it will generate a random number, put it in there, display it, and then the next number will overwrite that one. So we would have forgotten the number we had. Now, what we want to get to, we want to get to a stage where we can save all the numbers. We want to keep them in variables so that we can use them later on. Now, with this, do you agree we can't change this thing? We can't create like a num1, comma, a num2, comma, a num3, and so forth, and then expect this one to be num1 now, and then next time be num2, and so forth. We would think, oh, but so can't I use this I maybe and say num I, and then it will change as this one changes. But unfortunately, it doesn't work that way with normal variables because it just creates one. Um, so what we're doing now, like I said, our topic is arrays. And what an array is, let me show you. When we create it, so we'll also say They generally like to call it ARR just to say it's an array. So let's call it ARR num. And then its data type is an array. If you control space after that, it gives you these two options. Array C, array D. Let me just see what's D. It's not array D. Alright, yeah, I always use array C. I just thought, let's see what that does. Alright, so then what we do is, so there's your array's name, and then it will be of type an array. And then these are the positions you've got in the array, and this is the data type. So what this actually does, let me just show you with Excel. I love Excel to explain how memory works. So in our previous program, we had a num, and as soon as you created num, it sort of created a space in RAM, space like that, and it said this one's reference is called num. So every time we use the word num, it refers to this space. What we also did, we created an I. So it took up another space in RAM, called it I, and said, whenever somebody talks about I, just refer to this block. Now what I've done here with this program, as soon as you go array num, and then I say array from 0 to 10, what this did is it also created the name now, or the pointer is called rnum. But what that did, it actually created, oops, not right, that was that. So this actually created all of these spots for us. So how that worked, this one's, it's sort of like a street, I want to say. So this is your street name, and then each one of these is the house numbers that you can refer to. So we've got now rnum 0, which is that one, and a rnum 1, which is that one, and a rnum 2, which is that one. So for us in this one line of code, I actually created 10 variables. And the way we refer to, like this one, I'll just call with the word num. This one I'll just call with the word I. This one you'll now call with rnum, but then square brackets 0. And this is rnum square brackets 1. And if you understand this, this is exactly uh, rnum 2, and so forth. So you can refer to individual ones. What I mean with that is, if we created this, you can go and say, okay, rnum 5 must get the value of 60. So you can refer to the individual elements just like that. So they are 100%, I want to say, independent variables. But what's nice about it, with that one line, we created 10 of them. And the other nice thing about them, because our index, they call it the index, is inside the square brackets, we can actually, inside our for loop, now we can say rnum, and I can, in the square brackets, put I there now. Just do this also. So what this will do is, remember I is 1. So it's going to put in rnum 1, it's going to put the first one. Then I becomes 2, so then rnum 2 will get the next random number. Then I goes to 3, then rnum 3 gets the next number. And that will go through. Our only problem here, 'cause, 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 ' see this. Yeah. All right. So from 0 to 10, how many variables did I actually create? If I created an array from 0 to 10, how many variables have I created? So let's quickly count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes. So one more. Um, so it's not necessarily a problem, but what's important to remember is our first position is in position 0. So the first element is in 0. So that's why you remember our for loop always started at 0 and then went to 9. And generally our array will also create from 0 to 9. Oh, sorry. I'll just came back on. All right. Any questions so far that anybody's got? So for now, I want you to just understand that our numbers like our street name, and then each of these numbers are index. And then, so what we can do is when we create it, if we only want 10, we'll go from 0 to 9. And then our for loop needs to go from 0 to 9. And then we can use our num, and then we can put an I inside there, and then give it a random number. And then what we can do is we display it exactly like we did. So then we'll just say rnum with I. So you'll see with this one now, I removed my num part. Okay, that was just to explain. So we can remove this. So I'm not using num at all. Let's quickly run this. And then we click this, you'll see it works exactly the same. The difference, however, all of the numbers are stored in the array. So I didn't lose. So if after this button at this stage, if I want to display let's say I want to display let's just put a nice message here for us. Let's put that message, and then I want to display the second number is in which position. Remember, I'm going from 0. So my second number would be in which position? Yes. And then my last one would be in position 9. So let me just, so I'm going to put the word break afterwards, and then just display the second number and then the 9th number again. See, so there's our numbers. After the break is our second number and our last number. So just to show that after the for loop was done, all the numbers are still saved. They are in RAM stored there. So we haven't lost any numbers. So now on Tuesday, what we're going to do, I'm going to start showing you how can we now work with these numbers so that we can maybe sort them from small to big or from big to small. Maybe look for the biggest one, maybe look for the total, look for the average, and just work with these numbers because now all 10 numbers are saved in the array and we haven't lost any of them. It's not just a display and then forgotten. We're actually keeping them so that we can reuse them later for whatever reason we would want it. All right. Any questions on this, guys or girls? Yes, ask me. Yeah, you can type this out as well. Um, but yeah, it's just faster for me. I give it a name. I go colon, and then when I go ARR, I choose the array C, and it gives me all of that, and then I just take out the back piece. And then it's already in the right format. Then you can just change your size, and then remember an array, or something I didn't say, this integer part, you can make it obviously anything. It can be integer or it can be string if you want to put words in. We can make it reals if you want to put reals in. You can even make them booleans if you want booleans in there. Um, any data type you can put in there that you would want. That would be fine. All right. Any other questions? No, you don't. No, we're not using Excel. I just like to show you so that you can visualize what's happening in RAM. So we're not actually using the Excel for anything. I just wanted to show you when we created a variable and it generated a random number, it was placed in there and we displayed it. And then it generated another random number and it displayed, put it there and showed it. So we only kept the last number every time. But now we're generating a random number and then generating another random number and another one and another one. And then after all the random numbers were generated, we can actually refer back because all of them were saved. While in this case, every time it overwrote the one we did. So after the for loop, you could only access the last number. But with arrays, we're actually keeping all of our values. So if you're thinking of a hard drive or you're thinking of RAM, always see it as like blocks like this, where values are stored. And then they've got like pointers to them. And that's these names. So num is a pointer to this block in RAM where some value can be stored. And then these ones are then pointers to these spots. So no, yeah, so Excel was just there. You'll see even next week I'm going to use Excel to sort of explain when we want to sort numbers and just how we're going to shuffle them and so forth. But yeah, no, Excel is just nice to explain and maybe visualize what is happening in the memory of the computer. But no, we just do it just here, creating it there, and then we can use it here as if it was normal variables. All right.